All right. Good evening, my excellent biology students. Hope we are doing fine, and I hope you had a wonderful day. So, please, someone to confirm if I'm audible enough. Someone to confirm if I'm audible enough. Good evening, Sandra. We've got Harold, Anna, Frida, Memory, Matilda, Mary. Good evening, Albertina, Sandra. Okay, audible enough. Wonderful, wonderful, wonderful. So, someone to tell our fellow students in the group that class has started. Let me just send a text. Even today, network is bad. Are you having any network issues? Are you having any network issues on your end? On my end, everything seems to be okay. Network is proper today. So I hope everything is clear. Someone to tell me if I can start. Can I start? Can I start the class? All right, all right. So yeah, I think I can start. So we're looking at diffusion. We're still looking at in our previous class we looked at osmosis. We started osmosis. We didn't finish, so I'm going to finish osmosis today. Okay, I will finish up osmosis, and then tomorrow we're going to look at active transport. This is in preparation for the test, which is going to be given on Sunday. Okay. So I hope that you are studying, my excellent students. That's the only way. Okay, that's the only way for you to get that distinction. Ensure that you create a study timetable that you're going to be following. And if you don't know how to make a study timetable, I'll teach you on how to make a proper study timetable. We need a study timetable. So do not think that we still have time. Most GCE students, they think there is time. Could it be time? There is no time, my excellent students. Because imagine we're trying to cover up a 3 year syllabus, a syllabus that is supposed to be taught in 3 years. We are trying to cover it in months. So don't think we have time. Okay. So do not delay, do not procrastinate your studies. Make sure that you study. Start now. Because when it's time for your exams, there's pressure. There's pressure, trust me. So you have to start now when it comes to studying. Okay. So right now, as you still have few notes, make sure that you go through them. Study what diffusion is. Go through the notes. Do some research. That's what is required for you to get the grade that you want. Okay. So in our previous class, we discussed the types of solutions that a cell can be exposed to. Okay. We discussed the type of solutions that a cell can be exposed to. So your cells, you as a living organism, you are made up of cells, right? And those cells can be exposed to three types of solutions. Three. We've got hypotonic solution, we've got hypertonic solution, and we've got isotonic solution. These are the three types of solutions that cells can be exposed to. Hypertonic solution, hypotonic solution, as well as isotonic solution. Now, to define the three solutions, we'll start with hypertonic solution. So whenever you hear hyper, mukambirache hypertonic, hypertonic, hyper, what should come to your mind is this solution is highly concentrated. Remember the example I gave in our previous life class? I said that imagine there are two cups. We've got cup A and cup B. In cup A, there are 5 spoons of sugar. Okay, there's water and 5 spoons of sugar. In cup B, same level of water, but in cup B, there's 1 spoon of sugar. Between the two cups, you are going to agree with me that cup A has got more sugar than cup B. Therefore, cup A is highly concentrated with sugar, which is a solute. Okay, so cup A is highly concentrated. Since it is highly concentrated, that simply means it has got low water potential. Since cup A is highly concentrated, that simply means it has got what? Low water potential. That is a hypertonic solution. A hypertonic solution is a solution that has got low water potential and it is highly concentrated with a solute. Now, for those that don't know what a solute is simply anything that dissolves in a solvent. Monga mwamene ilili sugar, mukafaka sugar mu manzi, imasungunuka, it dissolves. So sugar is a solute. Another example of a solute is salt. Mukafaka salt mu manzi, isasungunuka. Therefore, salt is a solute. So anything that dissolves in a solvent is a solute. Okay. So we're talking about hypertonic solution. And we are saying that this is a solution that is highly concentrated with a solute and it has got low water potential. So if you are to compare hypertonic solution with the solution inside the cell, which can be a plant cell or an animal cell, you will notice that hypertonic solution has got low water potential while the solution in the cell has got high water potential. So follow me very well. Hypertonic solution is a solution with low water potential. And since that is the case, it also means that it is highly concentrated. Okay? It is highly concentrated. So in comparison with hypertonic solution in the solution in a cell, the comparison is that in a hypertonic solution, we've got low water molecules, and in a cell, we've got more water molecules. Okay? So we should keep that in mind. And then when it comes to hypotonic solution, yachinja pomanja, it is now hypo. Hypo. So for hypotonic solution, it's just the opposite. Hypotonic solution, it is similar to a solution in cup B. Remember, I said in cup B, we've got same level of water with that in cup A, but in cup B, there's 1 spoon of sugar. Since that's the case, cup B it is less concentrated. Cup B is less concentrated. When sugar chain on, even you when you test, if you're making zigolo, yeah, you just put, let's say, half a spoon of sugar. You will notice that sizanzuna, you even add more sugar, isn't it? So why do you do that? Because that solution which you have formed is less concentrated. Since it is less concentrated, that simply means it has got high water potential. Mulimanzia mbili, it has got high water potential. And that's the case with hypotonic solution. Hypotonic solution is simply a solution that has got high water potential compared to a cell. So meaning in a cell, there is low water potential. So hypotonic solution has got high water potential compared to a cell. Meaning hypotonic solution muli vimanzi vambili mu hypotonic solution. Hope you are following. I'm just reminding you of what we did in the previous class. Okay. And then tikangana pali isotonic solution. Isotonic solution yeve, the concentration of isotonic solution, it is equal to the concentration of that of a cell. The concentration are equal. Okay. There is no difference. The concentration in an isotonic solution and the concentration in a cell, they are at a state of equilibrium, meaning they are equal. Okay. They are equal. Yeah. So we need to understand these 3 types of solutions so that we can understand the next piece of slides. So are we clear on the 3 types of solutions? Miss Karen, how are you? Miss Helen? Naomi, yes, you're late, but you will catch up. You will catch up. Otherwise, are we clear on the 3 types of solutions? I have explained what hypertonic solution is. In simple terms, hypertonic solution, what should come to your mind? Nichi solution mwamene muli vishuga vambili. Therefore, it has got low water potential. Then hypotonic solution ni solution ina tushuga tungono. Therefore, it has got high water potential. Then isotonic solution, the concentration between isotonic solution and that of the cell are equal. We need to understand these 3 types of solutions. So I hope we're clear with the with the definition of the three solutions. Okay, Dorothy is clear. Okay, can I repeat? Anyone who is not clear, if you're not clear, please, this is the time. This is the time to air out. If you're not clear, make sure that you tell me. Okay. Otherwise, Destiny is also clear, so I can move on. Right? We can look at something else, isn't it? So Naomi is saying, I repeat. Okay. So hypotonic solution, Naomi, pay attention. Hypotonic solution, it is a solution which has got high water potential. What does that mean? It simply means it is less concentrated. If you remember in our previous class, I said, imagine there are two cups. We've got cup A and cup B. And these two cups, tafakamo mans, in both cups, we've put equal amount of water in both cups. In cup A, we've put 5 spoons of sugar. Imagine we put 5 spoons of sugar in cup A. And then in cup B, we only put 1 spoon of sugar. In cup A, there are 5 spoons of sugar that we've put. In cup B, there's only 1 spoon of sugar. Tavu dash tanachan, we've then stirred them up. If you taste, you will notice that cup A will be sweet compared to cup B, meaning cup A has got more sugar than cup B. Since that's the case, cup A is highly concentrated, cup B is less concentrated. So if we're talking about hypotonic solution, hypotonic solution is in cup B. Therefore, hypotonic solution is less concentrated. Okay? And at the same time, it has got high water potential, meaning it has got more water potential. Muli sugar ingono, muli manzi ambili. So it is less concentrated. So if we're talking about less concentration, we are referring to the solute, which is the sugar. And if we're talking about high water potential, we are referring to the water. So hypotonic solution is the same as the solution which is in cup B, of which I've said in cup B there's 1 spoon of sugar. Therefore, the solution in cup B is less concentrated. There are more water molecules than the sugar. Therefore, it is less concentrated with the sugar, but at the same time, it has got high water potential, meaning there are more water molecules. That is hypotonic solution, a solution that is less concentrated compared to that solution in the cell. So since it's less concentrated, that simply means it has got what? More water molecules. It has got high water potential. But when it comes to cup A, which has got 5 spoons of sugar, the solution in cup A is similar to hypertonic solution. They are the same. Hypertonic solution is a solution that is highly concentrated, just the same as the solution in cup A, which has got 5 spoons of sugar. So hypertonic solution, there are more solutes than water molecules. Therefore, it is highly concentrated with a solute, and at the same time, it has got low water potential, meaning there are low water molecules. That's the explanation on the two, hypertonic solution and hypo. So hyper, it is a solution that has got less water potential or low water potential, and then hypotonic, it has got high water potential. For isotonic, the concentration between isotonic as well as this the solution in the two cells, which is a plant cell or an animal cell, the concentration is the same. So if you compare the solution, which is isotonic solution, and if you compare isotonic solution and the solution in the cells, they are at a state of equilibrium. So let me give an example. Imagine we've got cup A and we've got cup B. In cup A, we've put water as well as in cup B. And in cup A, we've put 3 spoons of sugar. In cup B, we've also put 3 spoons of sugar. The concentration is what? It is equal, isn't it? That's the same even between an isotonic solution and a cell. Okay, so are you clear now, Naomi, as well as Matilda? I can move on, right? I think so. I think I can move forward. Okay. So now let's look at how these solutions affect an animal cell as well as a plant cell. We're going to start by looking at effects of osmosis in animals. Okay. So when you put an animal cell in a hypotonic solution, it gains water and eventually bursts. This condition is known as cell lysis. Remember, hypotonic solution, it is a solution that has got more water molecules. It has got high water potential. Hypotonic solution. It is a solution with high water potential. Therefore, if you put an animal cell in a hypotonic solution, it will gain water. Because why is that going to happen? Listen, my student, listen. If you look at the solution, which is hypotonic solution, it has got more water molecules, it has got high water potential than the solution inside the cell. So I will repeat again. Let me repeat because I need you to understand. Vingene. If you look at hypotonic solution, it has got more water molecules, okay? Or in other words, it has got high water potential compared to a cell, of which in this case it is an animal cell. So since hypotonic solution has got more water molecules than an animal cell, osmosis will take place, which is the movement of water molecules from a region of high water potential to a region of low water potential. And hypotonic solution has got high water potential. Therefore, water will move from the solution, which is hypotonic solution, going into the cell where the low water. So if you put an animal cell in a okay, okay, okay. So Anna, oh, I'm cutting. All right, so it's my mic which is not working properly. I think I need to change, but I hope you can get me now. Hope you can hear me. So the mic is the problem. Okay, I'm audible now. Okay, wonderful, wonderful, wonderful. So I hope you can get me. I hope you can. I hope I'm clear. Wonderful, wonderful. Okay. So I was explaining about the hypotonic solution, right? Right. So I said that when you put an animal cell in a hypotonic solution, it gains water and eventually bursts. This condition is known as cell lysis. Now, I was explaining why this is the case. Okay. So remember, a hypotonic solution is a solution with high water potential compared to the solution inside a cell. Meaning, inside the solution which is in a cell, there is low water potential. The solution inside the cell, there is low water potential. I repeat, the solution inside a cell, there is low water potential. In other words, there are low water molecules in the solution inside the cell. So, since that's the case, hypotonic solution has got more water molecules, and that will cause water molecules to move from hypotonic solution going into the solution inside the cell, because osmosis is the movement of water from a region of high water potential to a region of low water potential. Since that's the case, the cell will gain water, and when it gains water, what will happen? It will eventually burst. Now, why does it burst? Because the outer layer of an animal cell is the cell membrane, which is not strong enough to withstand the pressure. Okay. So I hope we're clear with that explanation. Otherwise, when you put an animal cell in a hypotonic solution, it gains water and eventually bursts. The condition is known as cell lysis. Cell lysis. So if they ask you in an exam, what is cell lysis? It is simply a condition where an animal cell bursts after being placed in a hypotonic solution. And the hypotonic solution is a solution with high water potential compared to the solution in the cell. Therefore, it will move. Water will move from where it is highly concentrated to where it is less concentrated. And it is less concentrated inside the cell. That is why it goes inside the cell. Once the cell gains water, what happens? It will burst. Now, when you put an animal cell in a hypertonic solution, the opposite occurs, which is it shrinks. This condition is known as cell crenation. Now, why does an animal cell shrinks after being placed in a hypertonic solution? Remember, we defined hypertonic solution, isn't it? It's nature defined. We said that hypertonic solution, it is a solution with low water potential compared to that inside the cell. Meaning the solution inside the cell now, it has got high water potential. So since the solution inside the cell has got high water potential, the cell will lose that water because water moves from where it is highly concentrated, which is a region of high water potential, to where it is less concentrated, which is a region of low water potential. Therefore, the cell will now shrink when you put it in a hypertonic solution, because then the hypertonic solution, it is less concentrated with water. Therefore, it will gain the water from the cell, causing the cell to shrink. So if you look at the diagram that we have, we've got a cell which is a normal red blood cell. When you put it in a hypertonic solution, cell crenation occurs, which leads to it shrinking, as you can see. And then when you put the same animal cell in a hypotonic solution, it gains water and it bursts, which is cell lysis. Are we clear, my excellent students? Clear? Are we clear? Someone to confirm if you are clear. Okay. Wonderful, 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 wonderful. So now let's look at how hypertonic solution and hypotonic solution affects a plant. So Destiny is saying not audible enough. Am I audible? Okay. Am I audible? Miss Helen, clear, sir. Okay. Am I audible? Very audible. Okay, wonderful. Okay, so now let's look at effects of osmosis in plants. Okay, effects of osmosis in plants. By the way, before I even talk about effects of osmosis in plants, going back to effects of osmosis in animals, if you put an animal cell in an isotonic solution, nothing happens. It will remain the same because the concentration in that solution and the concentration in the cell are equal. So nothing will happen. Okay, nothing takes place. There won't be any change. So if you put an animal cell in an isotonic solution, nothing happens. It remains the same. Now, when it comes to effects of osmosis in plants, when you put a plant cell in a hypotonic solution, it gains water but does not burst. Instead, it becomes fully budged. This condition is known as cell turgidity. So, whenever you're putting a cell in a hypotonic solution, it will gain. Be like a hypotonic solution, my student. When people come into your life, they should gain. Okay? Don't be a hypertonic solution. Be a hypotonic solution. Not yonse ndiwo draina chebantu, ndimo mudraina chebantu. No, don't be like that. Draining people emotionally, mentally, financially, physically, ndimo mudraina. Be a hypotonic solution. From today onwards, tell yourself, I am a hypotonic solution. Whenever someone comes into my life, they gain. They gain. So if you've noticed, whether you put a plant cell or an animal cell in a hypotonic solution, what will happen to that cell? It will gain. The only difference is that when you put an animal cell in a hypotonic solution, it will gain, yes, but it will also burst. But for a plant cell, if you put it in a hypotonic solution, it gains water, but it doesn't burst. Instead, it becomes fully budged. By fully budged, they mean chizazulira. In other words, like if you get like a container, you put it in deep freezer, maona mweka mapompekera. That's what happens to a plant cell when you put it in a hypotonic solution. It gains water, but it doesn't burst. It just becomes fully budged. And the condition is known as what? Cell turgidity. Okay, cell turgidity. So yeah, whenever you put a cell in a hypotonic solution, it gains. It has to gain. Okay, it gains water. But now when you put a plant cell in a hypertonic solution, it loses water. So whether it's a plant cell or an animal cell, it will lose water. So even a plant cell, once you put it in a hypertonic solution, what will happen? It will lose water, and the cell membrane will detach from the cell wall. This condition is known as cell plasmolysis. Okay. So if they ask you what is cell plasmolysis, it is simply a condition where a plant cell loses water once it has been placed in a hypertonic solution. So don't be a hypertonic solution. Be a hypotonic solution. Also, don't be an isotonic solution. Kind if someone comes into your life or people come into your life and you are an isotonic solution, nothing happens, nothing changes. They still remain the same. Ankara chest chmos chmos na chmos. So hypotonic solution, it causes cells to gain. Hypertonic solution, it causes cells to lose water. So yeah, any questions? Any questions, my excellent students? Otherwise, network for some students it's really bad, of which I'm sure it has to do with load shedding. But once network has been restored in your area, make sure that you watch these live classes. Are we clear? Otherwise, are we clear? Are we clear about the effects of osmosis in plants as well as animals? We're clear, right? All right, wonderful, wonderful. To end here, uh, in the group, I want us to do something in the group, which is making a study timetable. So I want to send a voice note emphasizing on making a study timetable. Test. Okay. So there's a question actually from Zingala. I like Zingala because she likes asking questions. So Zingala is saying, so both cells in isotonic solution, they don't change. Yes. So if you put an animal cell or a plant cell in an isotonic solution, nothing happens, Zingala. Nothing. They don't change. They remain the same. Miss Helen, kule mesa, every time it's you losing. But I think you get the point. Like when if if people are gaining when they're in your life, it's a good thing. Unlike if they are losing. So it should be a balance actually. Because listen, if you are a hypotonic solution and they are also a hypotonic solution, they'll be gaining from you, you will also be gaining from them. You get it right? Yeah. So meaning you'll be gaining and they will also be gaining. Mr. Easton, yeah, mwachedwa Mr. Easton. Naso ndepetienda ife. Ndepetienda zona. Or even done, sure, zona. Yeah. But tomorrow, 20 hours, make sure, yeah? So I want to talk about making a study timetable in the group, my students, because we need this. Trust me, we have to do these things now. Not at no tembegeze machi. That's when we become serious. No, 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 no. We have to start doing those things now. Okay. So we're going to end here for tonight. I will continue tomorrow. Okay. I'll continue with the live class tomorrow as we look at um, active transport. From me, Philip Koma, the excellent tutor. Have a good night, my excellent students.